All right, so let's get started. Um, so just to make sure that you're all in the right place, this session is about unit testing in Drupal, and more specifically, a library that we created that hopefully you will all come to believe the same thing that we believe, which is that it makes unit testing a little bit easier, especially in Drupal. So my name is Gerardo Gonzalez. I am currently working with a company called Civic Actions. We work with local and federal governments, some nonprofits, but for the past couple of years, I have mostly been working with DKAN, which is an open data platform built on top of Drupal. It started with Drupal 7, and um, as I mentioned, for the past 2 years or so, we've been working on the Drupal 8 version of it. And recently, I think this summer, we released our first official stable release of DKAN 2. And part of the part of some of the interesting things that came out of that work is this library called the mock chain. Uh, I am fmizzell in Drupal.org, GitHub, Twitter. So if anybody is interested on speaking about unit testing, speaking about open data, I'm also very passionate about agile and process and things like that. Um, let's have a conversation. Uh, okay, let's get started. This session is very heavy on demo and live coding. Um, I I hope that most of you feel comfortable with object-oriented programming principles, and there's going to be a little bit of that as it relates to unit testing. So um, if you're not very familiar with that, I mean, you can still stick around, but you might get lost pretty quickly. So just a disclaimer. All right, so unit testing. What is unit testing? I usually have these conversations when I start working with teams because for some reason we engineers, well, maybe we humans, we just like to stick to our terms and our terminology. And so when you say that you're going to be doing unit testing, people feel very uncomfortable if you haven't defined very well what the unit is. So some people believe that methods or functions might be your unit. Some people might consider in the Drupal context that a module is your unit. In object-oriented programming, you might say that an object is your unit. But I believe that the ultimate conclusion that we have come up, at least in the working groups that I've been a part of, in which we also try to be as dedicated as possible to test-driven development, is that ultimately what you care about is speed. You want to have as quick of a feedback loop as possible when you're doing your development. You want to be able to write your test, run your test, and get feedback very quickly. And so from that perspective, what a unit is or isn't as important as how fast your actual tests are. And so the reason why unit testing is particularly interesting in that context is that out of all the possible tests that you can write, unit tests are probably going to be the fastest available. But as I mentioned, the units are not important. So what we learn from unit testing is not necessarily what is or isn't a unit, but a lot of very interesting techniques have come up from people attempting at isolating pieces of code, at isolating these units that they believe to be important to them, things like test doubles or mocking and whatnot. And those are useful in many contexts. And so that's sort of what we're going to be concentrating on today is exploring what are these kind of tools that exist for unit testing and how can we utilize them in the context of Drupal and how can that help you with your tests and your test methodologies that you want to use in your projects. So for the purpose of this presentation, I'm going to be showing you a little module, a little sample test module that we created in which we're going to be creating our test, that we're going to be creating our test against. And then we're going to talk about three different things. We're going to talk about fake objects. We're going to talk about some utilities that PHP unit itself offers us for mocking. It's called the mock builder. And finally, we're going to talk about the library that we're creating as part of our DKAN development called the mock chain. So let's get started. Let me show you the setup. So we'll be in PHP Storm a lot as we do a lot of live coding in this session. But what you can see here is we in this dark root, this dark root is just Drupal. So we have Drupal core, we have the modules directory, and inside of the modules directory, we have a custom module called feature article. And this is the sample module where we're going to be writing our tests. So the main idea of the simple module is imagine that you had a website in which you wanted to have a feature article that shows up in the homepage every day. So this module, what it's going to do is when you select a feature, an article to be featured in your homepage, is going to make any other feature article no longer feature. So you can only have one feature article on your site at any given time. And so we have a little bit of logic in this module to make that possible. Let me show you how it works. So I have a vanilla uh, Drupal 8 instance here with that module installed on it already. So let's go try to add an article. Let's call this article 1. And so here I have this flag that I can choose to make this current article the feature article. And as expected, the feature flag is on. But then if we go and add a second article, let's call this one, oops, article 2. So now we're making this one the new feature article. And if we save it, we see that the feature flag is on for this one. But if we go and look at the first article that we created, we're going to see that the feature flag has been turned to off. So that it's very basic, but it's for the purpose of just having something that is semi-realistic in a Drupal environment and that we can write unit tests against. All right, let's go look at the code. So for all of us Drupal-minded people, we can already start imagining how could this be implemented. And it makes sense that on our node save hook, so when the new node that is being selected as the feature article is being saved, that we're gonna do some things to make sure that any previously featured articles are no longer featured. And that is exactly what we're doing here. So here's our very simple entity pre-save hook. And then all our logic is in this class with this static method pre-save. So we can go look at that code. As you know, in Drupal, we want to organize all our custom code under a source directory. And so we have this class here. And then for Drupal to become aware that the code exists, we need to use the right autoloading, which in this case is Drupal as the namespace and the name of the module feature article. So here's our code, and here's our pre-save method that we were calling from the hook. So here's all our logic, which is not a lot. So what is happening here? So first, we want to check if the article that is being saved is a feature article. If it isn't, then we do nothing. So we go ahead and return, we're done. If it is, meaning that we get past this if statement, then we want to get any currently featured articles in the system. And that's what this method is doing for us. So we expect only to have one, right? If the system is working correctly, we will only have one current feature article. Now we check that we got something. There is a chance that there is no feature article at the moment. But if we do have one, then we call this other method called defeature, which as expected simply removes the feature flag. So very simple. Okay, so let's say we just created this module. If you were doing test-driven development, you will already have tests. But let's say that you're not doing test-driven development, and now you want to have some basic tests to make sure that your module is working as expected. So how can we do that? Well, Drupal core comes with PHP units out of the box, and they have unit tests in core. So we know that that tool is available to us. How do we connect test through Drupal, unit test through Drupal? So we can put our tests in the test directory. Inside of that directory, we need to have a source directory again. And then there are a few special folders or directories that you can put inside of your source directory that get auto-loaded, of which one of them is this unit directory. So we put our test there. You can call your test whatever makes sense to you. In our case, we just created a class called our test. If we look at it, the only thing that's particular about it is that for PHP unit to understand that this is a unit test, you need to extend this specific class called test case. Drupal has some other classes that implement, that extend test case like Drupal PHP unit and I believe kernel tests, but you don't need to use those. I mean, you can, and it's great that Drupal offers those, but if you just want a plain PHP unit and you don't want any of the functionality that the other Drupal classes offer, it is enough to just extend the PHP unit framework test case class, which we have done here. Then in your class that is being recognized by PHP unit now, then any method that you have inside of that class is considered a test and it will be run as such. Another interesting thing here is to notice the difference here in the namespace. So for your testing classes, you want your namespace to be Drupal test, the name of your module, and then once again, however you want to organize things internally. So in this case, we put it inside of the unit directory. So that's why our namespace looks like this. So that Drupal can auto-load it. All right. So let me run this test so you can see that it works. Now this magical incantation that I'm doing here is just a wrapper to the PHP unit binary. So, okay, so as we can see, it ran our test here and the specific test function that we have in there, method that we have in there. And it's saying that this is a risky test because our test is not really testing anything. Okay, so how do we get started testing something? Well, we could choose, these are all static methods. So we could choose one of the methods to get started with. And I will say, let's start with the simplest one. Even though there isn't much happening here, this is all Drupal, right? We're using the field API to set a field to a specific value, and then we're using the entity system to save that node. So there isn't any custom logic here, but we could still have a test. And for our purposes, we just want to be able to display how can we, even though Drupal is doing most of the work here, how can we have a test that checks and makes sure that things are still working? So we're going to be testing this dfeature method. So the first thing that you do to test any functionality is to actually run that functionality. So feature article, dfeature, and we know that this needs an article. And so here is where our unit testing woes start. So we do not have Drupal available to us. We cannot ask the database for a node. We cannot create a node the regular Drupal way and then retrieve it so that we can pass it to this method. All we have available to us is auto-loaded class from Drupal core. So we do have some parts of Drupal available, but we don't really have a fully set up instance of Drupal that we can utilize. So how do we get an article? Here is where those utilities that I was telling you about can come into play. So one important thing to note here is that these specific static method needs an object that implements the node interface. So when node interfaces are used, when interfaces are used for type hinting, we have more possibilities. Like we could create a fake class or a fake object that implements the specific interface and use that for our tests as a mock object of a node interface. So what will that look like? And um, this is not a best practice. You do not want to have multiple classes in the same file, but just for the purpose of showing what that might look like, I'm just going to write my class here. So let's say that we're creating a new class. Let's call it fake article. And we want this class to implement node interface, since that is what our method is expecting. Okay, now PHP Storm, it's pretty cool, and I'm sure many IDEs have this, but we can tell it to generate all of the necessary methods to properly implement this node interface. And look at this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 methods just as part of the node interface. But the node interface is not a simple interface. It itself implements other interfaces like fieldable entity interface, which has a number of methods, and also entity interface, which has another big long list of more methods and accessibility and cacheable. So as you can see, we're going to end up creating a whole bunch of methods just to comply with the node interface, of which most of them will have no code whatsoever. They're going to be empty methods because our functionality is very constrained. But the point that I'm trying to make here is that it can be difficult, especially when you're dealing with complex objects, to create these fake versions of those objects. And that is why people created different solutions, like the ability for us to create test doubles or mocks, so that we do not have to go through this process of implementing these very complex interfaces and then choosing where our logic needs to live and all of this stuff. It allows you to target things more specifically, as we will see in a minute. Okay, so let's forget about this fake object option because it's gonna be messy and it's not gonna be fun. So we wanna get rid of this, and then we wanna try something different. Okay, so I mentioned test doubles. A test double is just a way for you to have something that appears as something else without actually implementing it. So in this instance, our test double, we want it to be an article, even though it is not an article. We want it to appear to the system as if it was an article that implements the node interface, but in the background, magic is happening. And we love that magic, and it doesn't matter if we don't understand how the magic works, as long as our test can pass. So let's try some of that magic. So PHP unit, and specifically the test case class, comes with a method that allows us to get something called a mock builder. So a mock builder, as the name implies, is an object that allows you to build mocks. The constructor requires that we give it which type of thing we're going to be mocking. So in this case, we know that we want to mock, well, it could be a node object, but it could also be a node interface object. Okay, so now we have a builder that is capable of producing a node interface object. And in the simplest possible scenario, all we have to do is ask the builder to give us a mock of that thing that we mentioned. Now there are two methods to get mocks here. We can use get mock, or we can use get mock for abstract class. An interface is not really a class per se, but it is considered an abstract class because it has things that have not been implemented in it. Effectively, nothing has been implemented in it. That's how interfaces work. But so we use the getMock for abstract class method instead of getMock. Okay, but effectively that is it. At this point, we should have an object that to the system will appear as if it was a node interface object. So let's see what happened when we run our tests. Okay, so our test is still risky because we're not performing any assertions, and we will talk about assertions in a minute. But as you can see, we do not have an error. Okay, maybe I skip one step. Let me remove the mock for a second, so you can see what the error that we were getting, that we will get if we did not use a proper object. So let's say that we're just passing a null thing to our method. So as you can see, we don't get yellow, we get red because there is a problem with our test. And the problem is that this dFeature method expects a node interface and we're giving it a null value. So here's the contrast of what will happen when you're giving it the incorrect thing, but we're not getting the error with the mock because the system understands this object as a node interface. And so that's why the error is not thrown. Okay, so those are the basics. You can create a mock very easily with PHP unit, but this test is also not very useful because we don't have any assertions. We're not checking for anything specifically, and also there isn't much to check in this method. So maybe we can step it up and go to the next level. How about this method here? This method's a little bit more complex. We're using different parts of Drupal now. We're using the entity query system in Drupal. We're using logging. We're using the entity system by loading a node. So a little bit more complexity. And so we can see how we can deal with something a little bit more complex. All right, let's remove these tests and let's start testing this new method. So once again, how do you start testing something? We simply want to run the code that we're trying to test. So get feature article is the method. And for this method, we actually get a more straightforward test because we expect get feature article, when it works correctly, we expect it to give us a node. So we could check on our test whether we're getting a node or not from this method. So we expect a node, and here's where the whole concept of assertions. An assertion is just a check that you're making of an expectation that you have from your code running correctly. So if our code runs correctly, we expect that article, this article object is going to be an instance of node. So we're running our code will give us something, and now we have an assertion. So this is a more realistic, possibly useful test. Let's run it. All right, so now we're getting a few more fun things. So we're getting an error because we do not have a dependency injection container set up. And for anybody that has done any digging into Drupal 8 and 9, you know that the majority of Drupal, if not all of it, is organized around this concept of the dependency injection container and lots of services that work with one another. And that is why very early you will get this kind of error from a unit test because a container is not available. So here's where our mocking or test double journey can start. Can we mock a container? And the answer is, of course we can. So another nice thing about some of these global methods that Drupal makes available to us is that they allow us to set up all sorts of interesting things inside of the system very easily. So here we have a method in which we can set a container so that a container is available to the system. So we will be creating this container mock in a minute, but we can go ahead and set it up here so that it is available when our get feature article runs. All right, so we know about our builder. We know how this works. So let's create our builder. And we want to mock a container. container, this is the right one. Okay, and to begin with, we just want to get the mock. Let's see what happens. Okay, so now we're not getting the error about the container not being available because we are creating a container mock and we are setting it so that Drupal is aware of it. But now we're hitting somewhere else where some object is expected and a method is being called on it, but that object actually does not exist. And I have explored this code, and so I know exactly where we're hitting that error. So I will guide you through it. Let's go through it. So here we're calling this entity query method, this global method. If we go to it, so this is the method. We notice here that we're calling another static method called entity type manager. This method calls the container and gets a specific service from the container. So here's where things start breaking down. So we have a container mock, but we have not told that mock how to behave under any specific scenario. So in this case, when the get method gets called on that object, the container doesn't know what to do, or even if it tries to do something, it's definitely not doing the right thing because it doesn't know what this entity type manager thing is. So here's where we make our mock a little bit smarter. So one of the main reasons for you to create mocks is to be able to set up behaviors that are required by your system, by your tests, without having to have the real things around. The way we do that with the mock builder is we use this set methods method, and then we tell it which methods we're going to be setting. In this case, we're going to be setting only this one, the get method. And then on your mock, you describe what should happen. So when the method get its call, we want to do something. In this case, we want to return something. What are we expected to return? We are expected to return whatever type of object this service is, entity type manager. I happen to know that that object is an entity type manager. So how do we do that? We do not have an entity type manager. Well, we have to create another mock. So we need another builder. We need another mock. So this builder is going to be mocking an entity type manager. Here it is, entity type manager. This method's incorrect. Then we get that mock. Let's call it manager. And then here in the behavior for the get method from the container, we can then pass that mock. So maybe some of you are maybe starting to discover where the name of our library comes from, the mock chain. And it's because in Drupal, these things are very common. We have an object that returns another object, which when you call a method on it, you return another object. And so for us to properly mock certain parts of Drupal, we need to have these long chains of mocks. And as you can see, this can get very verbose. Let's follow the path of this specific mock that we're creating here to its end, just so you can understand how many of these lines of code you're going to have just to be able to properly mock a little bit of our test. Just this part here where we get a query object at the end. Okay, so we were, so let's follow it. So we go here. This will return an object from the container, an entity type manager object, in which we call another method. So the entity type manager mock needs to mock the get storage method, which in turn returns another object. an object of the, I happen to know that it is a node storage object. So we get a node storage object here, which needs to be a mock. And then we call a method on that mocked object. So we need to mock get query on the node storage object. And then finally, that mock, the mock for this method, the get query method on the node storage object will finally return one final mock, which is a query interface object. So a long chain, just for something very small, it can get very verbose. And because of that verbosity, that is why we created the mock chain library. So let's see what it will look like if we were using the mock chain library. So first of all, let me introduce it. The mock chain library, uh, it's an independent library, is not directly tied to Drupal. Any PHP project can use it. As you can see here, we're looking at the page here for packages. So you can install it with Composer on any project that you're using PHP unit with. And I already have it installed on on my site. So I can start using it. So this is what creating a container mock would look like with the mock chain. So first of all, we need to create a chain. And this chain object is just a wrapper around that mock builder functionality that we've seen. So the chain itself is just giving what I consider a nicer interface around the mock builder, but it doesn't do any mocking itself. So that is why we need to give it a test case object so that it can utilize the mock builder capabilities from PHP unit. Okay, so as soon as you create a chain, you can start creating your definition of what the set of mocks that you're creating are gonna look like with this method add. So we can add a definition. The way these definitions are constructed is that you tell it what kind of object you're gonna be mocking, what method, and what it will return. So as you can see, we have a lot of information that it used to take different lines of code with the mock builder approach into a single method. So we know that we want to create a mock of the container, and we know that we want to mock the get method. And whenever that get method gets called, we want to return an entity type manager. So the mock chain knows that if you give it a class as the return value for a method, it needs to create a mock of that type. So we get that functionality in one line of code. Now we know that the chain continues, so we can also define how the entity type manager should behave. So we know that when the entity type manager get storage class, I believe that's what it's called. Yeah, get storage. The get storage class gets called, it needs to return a node storage object. And we also know that the node storage, we need to mock a method in it called get query. So get query, and that should return a query object. Actually, let's do the query interface. Query interface object. And I believe that's the end of our chain. So at that point, we're back to our code. Our code is asking Drupal for this query object. And then at this point, we start using some of the things from the query object. But let's stop it there for now and see how this works. So the last thing, just like with the mock builder, is we get a mock from the chain. So you create your chain and then you retrieve the mock, which now we have in this variable called container. So this container, it's a container object that understands certain things about other mocks that it needs to that it needs to give to the system. So let's try it, see what happens. Okay, so we didn't get an error about the query interface or the container or anything like that, this is back in our code. You can see here, we're in our feature article class, line 29, as we will expect, line 29, because we have not mocked access check, condition, or, well, these two methods. We haven't mocked either of these things in the query object. And that is why we're getting that error. So we could go ahead and do that so that we can move on to line 32. Okay, so now we need to improve the definition of our query mock. So the query interface mock, we want to mock the access check method. And what do we expect that method to return? Well, as we can see, we're chaining these methods, which means that the access check method should return the query object again, so that then this chain method can behave on the query object again. So we expect to return the query object. And now we also need to define another method for the query object. That method is condition. And that one also needs to return itself. One little thing here, if you feel like this is redundant for you to be telling the mock chain that you're defining two methods for the same object, the query interface, there is this special method with 3 Ds. Yes, not a proper or real word. But with that one, the mock chain will remember whichever one the last object that you were creating was, and you don't have to give that first part of the definition. So this means that we're doing a mock for access check and conditions on the query interface object. All right, now we can run our test again. Okay, and we got past that line, and now we are in a different part of the code, the for each loop in line 34. So we got a proper query object. Oh, but look, we missed one more method. We need to implement an execute method on the query object that is expected to return an array of node IDs. So we can do that last piece to hit our for each and hopefully the end of our function. Okay, so one last thing for the query object, the execute method. And here's where our chain ends. So the execute method gives a real thing, not another mock. In this case,
we have 2 Ds.
Correct. We have more than 1 D because this one is a separate method. All right. So here the chain stops and we're returning something real. What is expected is an array. We're going to send an empty array just so we don't have to deal with the for each loop at this moment, and we will deal with it in a minute. So let's go really briefly. Let's run the tests. Okay, so our test ran all the way through. You might not be able to realize that because it's still red, but the reason why I know is because we're failing on our actual assertion. If you remember, what we're checking is that we're getting an article back, and we are not. We're not getting an article back. I can show you, we're not getting an article back because we're returning an empty array, which effectively makes our code go to null, which is obviously not a node article. So that is why our tests are failing. And I want to get our test to pass, but very briefly, I want to show you something that is very useful from PHP unit, and that is coverage. So sadly, coverage will not, information about coverage on your code base is not generated if the tests are not passing. So we're gonna cheat for a second. and make this test pass no matter what. So we're gonna assert that true is true. And we're gonna run the test again just to see it green. Oh, I'm doing other things that I shouldn't be doing. Okay, so now the test is green. Oh, I didn't generate the coverage report. So if you're running PHP unit and you have Xdebug enabled on the system where your PHP unit code is running, you can generate these coverage reports, which are very useful, but also addictive. And it's not very important for you to have 100% coverage. It's more important that you're covering the right things. But it is a great tool for you to be able to see what parts of your code are being touched by tests, which parts are not, and different things like that. So some coverage was generated here for us, and we can go look at it. So if you use the coverage HTML, this is going to generate an HTML report that you can access on a browser. And so here we can see that from our code base, which is a single class, we have covered with our unit test 35% of the code base here. And we can go inside here and see exactly what's being touched and what is not. So the red things are not being touched, but the green things are. And we can see here exactly what I was mentioning, that we're touching this with our mocks all the way up to getting an array, an empty array here for NIDs. Then we're not going into the for each loop, and we end up hitting the null. So this can be a powerful tool that we get for free just by using PHP unit instead of other testing mechanisms or frameworks. All right, we only have 15 minutes, and in theory even less because the next session will be starting then. So let me kind of jump ahead a little bit. If we wanted to mock all of these parts in here, we will need quite a few more mocks. So we will need a logger mock. We will need this node load mock, and those can be kind of complicated. So not complicated because they're difficult, but just complicated because of the amount of time that we have. So I kind of have them pre-populated here for us. And I would like to run through some of the interesting things that are happening there. Okay, so this is our full mock for our test to pass. So let me run it and we'll see a green, not because the assertion is that true is true, but because our assertion is that we're getting an article node, as you can see here in line 46. So let me run the test. Oh, the test is not passing. Okay, I need the options. Oh, I have all of these things that have not been, I need to add the options to all of these things. So I want an option. New options from the mock chain. Okay. We also need these classes. I want the logger channel class. We need the entity repository class. Come on, PHP Storm. I know Zoom is a resource hog, but you're taking too long. Well, I think I have my classes. Let's see if this will run correctly. Entity repository, entity repository. Still red. Entity repository. Oh, it's supposed to be entity type, not entity repository. Entity type. entity type repository class. All right, let's see if we get it this time. Okay, we're green. And I can also prove over here that now we're walking through the right parts of the code base. So as you can see here, we're no longer hitting the null, but we are going inside of our for each loop, and we're actually doing this logging, and we're actually doing this node. All right, so let's look at the code that is actually making this happen. So we have more chain things, but that is not that interesting. What is interesting is this options thing here. So what was happening was that we mocked this get method for the container, and we were hard coding the return to be an entity type manager. But in any complex kind of Drupal system, you know that the container is going to have to return different kinds of services depending on what the service that is being requested is. And that is what this options object from the mock chain allows you to do. It allows you to return different types of mocks depending on what the input is to the method. So what we're saying here effectively is that if the get method gets called on this container mock object with the input of entity type manager, we're gonna return an entity type manager mock. But if they call it with the input of logger channel, that default, which is exactly what is happening right here in our code base, then we will return a different kind of mock, a logger channel mock, and the same thing for the entity type repository. So this is a semi-straightforward way of making our mocks more powerful by being able to react to actual input to the mock methods that are being given. So that is one thing. The other thing here is that I'm creating a separate mock over here of just a node that is then being returned as part of the execute method. So this is how we're mocking the part of the node system that actually loads the nodes. Oh, actually, no, this is returning just the identifier. What are we, oh, here, load. So the node storage load method is being mocked, and we're returning this article node mock that is being created up here. So this might look a little complex. I mean, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 20 lines of code for what effectively is a very small function that is mostly using Drupal APIs. But also remember that it is also just 20 lines of code to mock the entity, parts of the entity system, part of the login system, query interface system. So in the big scheme of things, it's not really that much code for mocking lots of different complex parts of Drupal. I would like to have a few minutes of questions, so I'm not going to go into the last part that I wanted to go into, but I do want to conclude the presentation by addressing a question that came to me on one of the first trial runs that I did of the presentation, and somebody asked, given this, semi-complexity or how, how intricate this mocking has to be for Drupal, why would you choose to use that instead of something like the kernel tests that Drupal provides, in which you actually have an instance of Drupal so that you don't have to mock all of these subsystems? And that is a very good point. I personally do not use kernel tests that much. I dislike them, but that doesn't mean that I don't agree with the point about integration tests. What I use a lot is this project by Moshe. It's called Drupal test traits. This allows you to also have like an instance of a Drupal website in which you can run PHP unit tests against. So this is what we use for integration test. So when did you choose to use unit tests? The kind of line in the sand that we're drawing for ourselves at the moment is we try to do as much integration tests as possible. And by integration tests, I mean anything that is using more than one component at the same time, even if it's written in PHP unit. So any of those integration tests we do for all of our happy paths. So the basic thing that we're seeing here in our code coverage. This is our happy path. We get a node, we do things, we're done. Now this return null path, this is the unhappy path. This is when we don't get what we generally expect. And I will say that for those unhappy paths, we want to use unit tests just because sometimes it's very difficult to set up your system or create a mocked version of your Drupal instance or your Drupal site that hits that specific part of the code directly. While with your mocks, even though they are a little more complex, you have a lot of control. You can decide exactly what is going to be returned so that you can hit those different parts of your system and be able to have complete coverage of all of the things that you need to be testing. All right, I know that was a whole bunch and I haven't been paying attention to the chat. So let me see if there are any questions that I can address in the last few minutes.
Hey, Gerardo, we actually need you to stop now because we only have 8 minutes
Okay,
to get the
perfect.
next speaker set up, but everyone can
Yes.
continue asking questions and sharing resources over in the Slack channel.
Perfect. Let's do that. And also hit me on Twitter if you have any questions. And thank you so much. And now I will let the next speaker have the floor. Thank you very
Thank
much.
you. That was great.